Welcome to this discussion. We are still looking at structure and bonding. Last time we looked at bonding and we said a bond is a mutual force that exists when elements of either the same or different atoms combine. We looked at the four types of bonds. We said we have an ionic bond. 2, we talked about a covalent bond. 3, we talked about a dative, also known as a coordinate bond, and we also talked about a metallic bond. Today we are going to look at an ionic bond, and we said an ionic bond is a bond formed when there is complete transfer of valence electrons from one atom to another. When we talk about valence electrons, these are electrons in the outermost energy level of an element. Another thing we said about ionic bonds is that they exist between a metal and a nonmetal, between metals and non-metals. Let us use a few examples to explain how these kind of bonds are formed. For example, if we are forming sodium chloride, sodium chloride is a compound of sodium and chlorine. Sodium is in atomic number 11 with an electron arrangement of 2, 8, 1. We also have chlorine in atomic number 17 with an electron arrangement of 2, 8, 7. For sodium to be stable, it has to lose 1 electron, and for chlorine to be stable, it has to gain 1 electron. In this case, when sodium loses its valence electron, chlorine is going to gain that 1 electron in order to become stable. In this case, we can say sodium has transferred its 1 valence electron to chlorine, leading to the formation of an ionic bond. In this case, we are going to use crosses and dot diagrams to show how bonding takes place between sodium and chlorine to form sodium chloride, which is an ionic compound. We are going to begin by drawing sodium. The atomic structure of sodium, the first energy level has 2 electrons. We close it. Then the second one has 8 electrons. And the last energy level has 1. Sodium is combining with chlorine with an electron arrangement of 2, 8, 7. So we are going to draw chlorine atom here. The first energy level has 2 electrons. The second one has 8. And the last one has 7. These are 2, 4, 6, and the last one is here, which is the 7th one. So sodium is going to transfer its electron to chlorine, and the compound formed in this case, remember, sodium will lose its 1 electron to form sodium ion with an electron with an ionic arrangement of 2, 8, and chlorine is going to gain that 1 electron to form a negatively charged ion with an ionic arrangement of 2, 8, 8. To draw now the structures formed, we are going to begin by looking at sodium again. Sodium has 2 electrons in the first energy level. then 8 in the second energy level after losing the 1 electron. So since this is an ion, we are going to put it under square brackets. Then we indicate the number of electrons that it has lost to form sodium ion. It is also combining with chlorine. Chlorine gains 1 electron to form a chloride ion, and we are going to start by drawing. So these are electrons of sodium. Let us maintain them by using the crosses. Then now we go to chlorine. The first energy level has 2, we close it. The second energy level has 8. The third one has 8. But remember, it had 7 and it gained 1 from sodium to make them 8. And in this case, now we have a chloride ion. Ions are put under square brackets. Then we indicate the net charge, also the number of electrons that it has gained to acquire its current state. So you can still avoid drawing their atomic structures. Then you draw the structures of the ions formed when sodium and chlorine combine. In other words, we have sodium reacting with chlorine to give us sodium chloride, and sodium chloride is an ionic compound because the ions are joined by an ionic bond. Let us look at another example. Let us call it example number 2b. Let us look at the formation of magnesium chloride. So we have magnesium Mg, we have chlorine Cl, but since magnesium has a valency of 2, it will give its valence electrons to chlorine to form magnesium chloride. Magnesium is in atomic number 12 with an electron arrangement of 282. We also have chlorine in atomic number 17 with an electron arrangement of 287. We are going to start by drawing the structure of magnesium. The first energy level has 2 electrons. We close it. The second one has 8. And the third one has 2 electrons, which it is going to lose for it to be stable. We also have magnesium combining with chlorine. Chlorine has 2 electrons in the first energy level. Then we have 8 in the second energy level. Then we have 7 in the third energy level. But remember, chlorine requires only 1 in order to become stable. We are going now to look at what is going to happen next. Magnesium loses 2 electrons to form magnesium ion with an ionic arrangement of 2,8, and the chlorine is going to gain 1 electron to form chloride ion with an ionic arrangement of 2,8,8. Let us represent magnesium ion. We are going to have the first energy level having 2 electrons. Then the second one has 8 after losing 2 electrons. Since this is an ion, we are going to put it under square brackets. Then we indicate the number of electrons it has lost by writing 2 positive on the upper right hand side. This is 2 positive. It is combining with chlorine, so the chloride ion has an ionic arrangement of 288, so the first one will have 2, the second energy level will have 8, electrons, the third one will also have 8. Remember, initially it had 7. It had to gain 1 electron from magnesium in order to be stable. But remember, this is an ion, and therefore we put it under square brackets. Then we indicate the number of electrons it has gained. But remember, magnesium is losing a maximum of 2 electrons, and therefore we need 2 of chlorines to completely absorb the 2 electrons that are coming from magnesium. Remember, this is magnesium combining with chlorine to give us magnesium chloride. So when magnesium combines with chlorine to form magnesium chloride, the compound formed, which is magnesium chloride, is an ionic compound. And we said ionic compounds are joined by ionic bonds. So let us look at some of the characteristics of ionic compounds. Characteristics of ionic compounds. 1. Ionic compounds are soluble in water, since they are made up of opposite charges, because they are made up of opposite charges which get attracted to polar water molecules. Number 2, we say that ionic compounds have high melting and boiling points, and this is due to the stronger ionic bonds. These bonds require a lot of heat energy to break, hence high melting and boiling points. Another thing is that ionic compounds do not conduct electricity in solid state, because the ions forming the compound are not mobile. We can say ionic compounds only conduct electricity. They only conduct electricity in either molten or in solution form. Why? Because in either molten or solution form, the ions are mobile, and therefore they conduct electricity. Thank you for watching, and in case you are watching this channel for the first time, kindly take 1 second and click the subscribe button, so that anytime we produce a video like this, you will automatically be given a notification.